Scaling. This is going to be a video about looking at scales. You probably might have seen this before through little Lego pieces or models, puzzles. One thing I found online was playing with cars as a little child. I had these models and they always said something with a colon. So if we were to read this, this is the die-cast guide of NASCAR collectibles, and this one looks bigger than the other one. It has 1:24. This is 1:64. So that's a a scale factor of comparing this to the actual size. This, in essence, basically is 24 times smaller than the actual car. This is 64 times smaller than the actual car. So basically everything of this car is 24 times smaller than the actual one, and this one, everything of this is 64 times, because if we just did 24 times smaller for the wheel and not for the headlights, things are not going to be proportional. Everything has to be proportional, so everything has to be 24 times smaller. So what is a scale factor? Scale factor basically is a enlarged or a smaller version of the actual one, and most of the time you're going to see a number with a colon that's separated by the two numbers. So this represents sort of the scale by the colon. 1:10, this means that it is 10 times smaller. So what you have is 10 times smaller. So I'm going to write what you have is 10 times smaller. And since this one has, I'm going to change colors. Seems like purple is not a very good fit for this. Oh, green is going to be even worse. Green on green. Let's just stick to yellow. Since your number, the first one is 10, well, that means that yours is going to be 10 times bigger than the actual. So what you have is 10 times bigger than actual. So how to get this and not be confused by it? I always try to think about the scale factor ratio is that the first number is always about you and your image and your model, and the second number is always about the actual or the original actual length, actual size of the object. So just to be a little bit narcissistic, you're going to think about the first number as you and your image and your diagram. So your sort of diagram or your image. So how we want to do this is whenever you see a scale factor, you want to you can change this into a fraction into this formula. So the scale factor is equal to the image length divided by the actual length. So the image length is the first number, which is your image length, and the actual one is what you see. And how you want to do this, how you want to figure this out is anytime you have a number like a scale factor of 1:5, you can always change this into fraction, which is 1/5. 1 is what you have, your image length. 5 is the actual length. So how do we calculate this with these things? If you look at this Ferrari, this one is 1:18. So basically 1/18. This is your image of your Ferrari, your model length of your Ferrari, and the 18 is the actual one. So how do we determine what the actual length is if we're given this ratio? So here, this is how we do it. Since your image is 24, this is what it says, 24, we're going to say 24. And this is divided by an actual. We don't know what an actual is because that's what we're trying to figure out. And since we're comparing ratios, we need to put equal another fraction. And this another fraction is your scale factor, so 1:18. You can always flip-flop this the other way around, and it's still okay. So how do we calculate this? You're going to cross multiply. This is going back to solving equations. So 24 times 18, let me see what that is. That is going to be 432 centimeters is equal to the actual length. So the actual length of your Ferrari from this scale is 432 centimeters, which is a little bit over 4 meters, which makes sense. So let's look at this one. This one is 1 to 24. It's a smaller scale. So change this into fraction, 1 over 24. And anytime we are comparing these scaling, we are comparing ratios. So this is going to be equal to another fraction. What we have is 18 centimeters. So that's what you have, or what I have, which is 18 centimeters. We're trying to find the actual, which is at the bottom. Oh, actual. So then you're going to cross multiply. You're going to see that 24 is multiplied by 18 again, which is 432 centimeters. This is equal to the actual length. That's how we just figured it out. You have to keep in mind though, not all your questions are going to be figure out the actual. Sometimes you're going to be finding out what your image size is. So if you have, say, a hockey stick, let me just make this question top of my head. Hockey stick that is, let's see, 200 centimeters long, 2 meters. You want to do a 1 to 10 scale down version. So what is your image length? So if you were to draw this on an image on a piece of paper, what is the image length? That's the question. So recap, if you're drawing a hockey stick, that's a big hockey stick. Hockey stick, 200 centimeters long. This is the actual size. What is the image length if the scale is 1 to 10? So you set this up, 1 to 10, anytime you see that ratio, break it down into the fraction, 1 to 10. This is equal to, so what do you have so far? Do you have an image length? You don't have the dimension, so this is the image length. You're going to keep this as the image length. That's what we try to figure out. And the actual length we have, which is 200 centimeters, so you cross multiply. You can notice that this is separated by 2 equal signs. So 1 times the 200 is 200 is equal to 10 I for image length. Let's do that. And then we're going to go, and since we have 10I, we're going to divide by 10 to both sides, and we're going to cancel this to 20. So what is this saying? I is equal to 20. That means your image length, the one that you're going to draw, is going to be 20 centimeters long on your piece of paper if the scale is 1 to 10. So if you're going to draw this on this piece of paper, your actual hockey stick is maybe this long, 200 centimeters. Your image length could be like this. So that's what you calculate. So basically, recap is change your scale to a fraction, set up your ratio with an equal another fraction, and then plug it into the formula. So the last thing we have to do is looking at how to determine the scale factor. How do we determine the 1:5 or the 6:1 or whatever these numbers is? This is the scale factor we have to figure out. So remember, the formula is scale factor, oh, I'm missing an E over there, is equal to your image length, so which is image length, divided by the actual size. That's the formula. What do we have for an image length? 10. What do we have for actual? 300. Since this is your scale factor, remember your scale factor, factor is always with the something colon something. You have a number here, some number here. And remember, if we were to be given 1:10, sort of backtrack, this is equal to 1 over 10. Okay, so basically this is your first number, 10, and this is your second number, 300. But this is sort of confusing because it's 10:300. So how do we make it so that it is 1? So we have to reduce this fraction to have this equal to 1. So in order for 10 to get to 1, you have to divide by 10. And if you divide the top by 10, you have to divide the bottom by 10, which gives you 30. So this fraction 1 over 30 is 1 to 30. And that's your scale factor. There you go. So that's determine your scale factor. So to recap, plug this stuff into the equation. Image divided by the actual. Get the top number to 1 because this would make it 1 colon something. If your scale factor is the opposite, then you want to do the bottom one, but that's just kind of confusing you. So just stick with that first and try that out. Try some questions. Hopefully this has helped you. All right, see you next one.